So remember, what we've been working on is completing that square. Right? And we found out that in standard form, when it looks like this, with no value in front of x squared, we can complete the square pretty easily, right? That represents a rectangle, that's a square, we don't care about that. And the formula we came up with is we cut the rectangle in half, right? So what's half of b? B over 2, right? This will become x plus b over 2. Inside here, right? That's the shortcut. That's what would end up happening when we make a square. That's x plus half of b, right? On both sides. And in order to balance that out, well, we put in b over 2, half of it, right? And we squared it, right? Isn't it a square b over 2 by b over 2? So we have to add b over 2 squared to this side. If you're confused, let me show you. Let's make an example. Y equals x squared. Give me an even number.
12.
So when I cut it in half, it's not too bad. And then any number here, right? 5. So what I would do is I would cut that in half, right? And that's going to be the dimensions of my square that I add to both sides. So I've got this. And we said half 12 is 6, so we're going to add 6 squared to both sides, right? Because that's the little piece of square we got to add in, right? And we know this will all become this, right? A perfect square. That's x plus 6 in dimension. Cool. And then we move stuff around. But do you see the connection here? We cut this in half, and that's what goes there. We cut this in half, and that's what goes there. You cool with that? Now, what do we add to both sides? We added b squared cut in half, right? That's what we did. We cut it in half and squared it. That's where this came from. So if we cut it in half and squared it to this side, we have to cut it in half squared to this side. So cutting it in half is b over 2, yeah?
Yeah.
What's b over 2 squared? B over 2 squared. To square it means times it by itself, right? So in other words, this. What's that going to be? Do you see how we square both the top and the bottom? And that's because when we multiply, that's what happens. Right? We times it by itself. So we have to add b squared over 4 to both sides. Why? Because we cut it in half and square it. And that's how we got here, right? Cut it in half and square it. Right? Cut this in half and square it. Are we cool with that?
Yes.
For real?
Yeah.
Tickler, you with me? All right. I don't only want you to do it with numbers on the quiz. You're also going to have to do it like this. And then, in order to get it in vertex form, we do this, right? We subtract it. So this is our formula. That's our formula, right? Whatever that is, moved over. We cool with that? Now, that's with no number in front of it of x squared, otherwise known as 1 in front of x squared, right? If there's a in front of there, what happens? Is everybody cool with this? Before I move on, I want to make sure you're good with this. Yes. Logan, you with me on this? Okay. This gets squared, right? Because we cut it in half and squared it and added it to both sides. Just like we did down here. Cut it in half and squared it, add it to both sides. So we cut that in half and squared it, we add it to this side. Cool? All right. With a in front. Maybe you're not so clear on what we do. Let's make an example. We can go from there. Let's use real numbers. Y equals, give me a number for a.
3.
2x squared. Give me an even number for b.
4.
And then any number for this. Let's just do 5. Okay.
15. 11.
To get this in vertex form, what did we do? What do we do? Divide the middle?
Oh wait, no, you gotta pull out, man. Pull out.
We got to do that, but we first have to pull out the 2. And then we can't pull it out from the 5, which is fine because we're just going to leave the 5 out here, right? Now again, if we put it back in, we get the same thing. Cool? We did not change the problem, we just made it look different. And now we treat it just like we would normally, right? inside the parentheses, we're going to cut this middle in half, right? And we're going to square it and add it.
Wait, I think he changed the formula too.
It will change the formula a little bit. We cut this middle in half, right? You with me? Right? That's what we would do. Now, the problem is I didn't just add 1 squared to this side. What did I actually add? What did I actually add to this equation?
1.
Well, 1 squared is 1, but not just that. When I put back that 2, what is that going to become?
2.
Yeah, 1 squared times 2, right? So that's what I really added to this side when I put that in there. Right? Without it there, that 2 doesn't go to anything, right? So it doesn't matter. But when there's something there, it's going to double it. So I really added plus 2 to this, didn't I? So it needs to be 1 squared times 2, otherwise known as 2. So we do 1 squared times 2. You cool with that?
Yeah.
Right? That's how that affects it. You have to have the big brain play and remember that that's going to affect it. So if that was 3 squared, it'd be 3 squared times 2 on this side. Okay? That all becomes a square. Right? Perfect square. And then we subtract that over. Could I simplify that? Yep, but I'm not going to. Does that make sense? Right, I just moved that all over. Could I simplify it? Sure. I just want you to see the logic of where it came from. Because when I do it with letters, it won't simplify, right? Yeah.
Where did the 2x go? And the
So remember all of this together, right? That is a rectangle plus a square. That little bit completes it to a perfect square. And so now we have a perfect square. A square that's x plus 1 by x plus 1. Right? All of this becomes that. Because we completed it to make it perfect. Okay? All right, so now let's do it with letters. Gentlemen, I will move all of you. I swear to God. Indiscriminately. All right, so what do we do first? We have to pull A out of B, right? Now, here we could do it because we could pull it out, right? It worked out nicely. Here, we've got A and B. When we pull stuff out, it's like division, right? So what we do is this. If you're not paying attention right now and you're going to whine about how we have this on the quiz on Friday, you have no one to blame but yourself. Good thing I record. All right, so last time I'll mention it. Does this, when we put it back, get us that? We get ax squared times a and divide by b cancel, right? So we didn't change anything. That's what pulling out is. It's dividing but also having the multiplication to cancel it out already, okay? That's it. So now we're here, and now we treat this just like we normally would. We have to divide this by 2. What's half of b over a? B over a, or 2a. 2 times a, right? Does that make sense? Right? B divided by 2 with an a on the bottom. You guys with me on that? And then we have to square it, right? Don't we cut it in half and square it? So normally what we do after we get to this part, right? We cut it in half and square it, right? So for this, I pulled out the a, and that got us here, right? With me on that? And then I cut it in half and squared it. Cutting it in half puts a 2 on the bottom, right? Divide by 2. And I squared it. Better? It's weird with letters, but we've been doing that with numbers all the time. It's just with numbers this simplifies, right? Okay, good question. All right, so now we're here. Now, I added this, so I got to add it over here. But the thing is, I didn't just add b over 2a squared. I also add that times a. So I've got this. What I really added was this times a, right? That a is going to affect it, right? That's what I really added to this equation when I plopped that in there. Okay? You have to have the big brain play. So what would this be? Let's simplify that. So this means times it by itself, right? So that's going to be b squared over what?
4a
4a
squared.
squared, right? b times b in the top, 2a times 2a in the bottom. Okay? Now, this means times a, right? So we have a in the top, and we're dividing by a twice. So if I had this, how would that simplify? Well, that's just this. Whoops. Right? That becomes 1. A divided by A is 1, so we get 1 over A, right? So you see how I have an A in the top and 2 A's in the bottom? It cancels one of the A's in the bottom. Does that make sense? So what that is going to equal is this. We cool with that? Are we cool with that? See how those go away, right? That's the same as this. A divided by A is 1. 1 over A is this. Cool? Mitchell? So that's what we really added. So I have to add that to this side. Cool? Now let's do some math. Our formula altogether is going to be this. That is a perfect square. It becomes this. You with me on that? Right? That, whatever that number is there goes down here. Right? And then I move the other over. That's the full formula. Okay? That's what we've been doing in letters. I need to see that. I need to see the explanation. I'm going to make you on the quiz draw the box out for things, right? Are you guys okay with drawing the box? Okay. This is the general formula. We're going to mess around with this today. Okay? Cool, cool, cool. I know. Troy does. Troy Baker. He comes in almost every period or so as he's passing through the hallway and puts a new thing up on the back wall. Because he misses being in this class, and he figured he would decorate the back wall because I started doing it.
You have never done it since.
I have, I just haven't done it in your class. All right. I want you to try this one on your own to get used to the numbers before we start messing with stuff. Here it is.
Wait, CJ.
Oh, let's do this. Let's do that. Make that an 8. Get that in a vertex form. What's going to make this problem hard? There's a 3 in front. And why is that difficult?
It's not even.
You got to pull it out, and it doesn't pull out evenly from 8. So what's that going to do when you pull it out? It's going to make a fraction. Go get it. Work together. Life is not about what you do, it's who you do it with. Yo.
You just put a variable under it?
That's an 8. So you're doing with numbers right now, okay? Get this in vertex form with numbers, okay? So we want it to end up looking like this.
Control the movement skew.
That's an 8. Sorry. That's an 8. That didn't help. It's an 8. Right. Get in this form. Go, 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 go.
Is that good?
Is it possible to get the...
Wow. Thanks, CJ. Thanks.
Is it?
Yes.
No thanks.
That works.
All right, guys, stop. Get to work. It's gonna be a fraction. That's okay. Now remember when you add, so you skip this step, right? You jump straight to here. You add in the 8 over 6 squared. You have to add both sides. And you have to so I'm going to show you why that is. Okay. Don't skip steps and you'll be okay. It's okay to skip the steps when there isn't a number in front of here, but when there is a number in front, you want to watch out for that. Jason, what's your question?
Okay,
Yeah, we'll have a 3 and you got a 4. All right, we've got some confusion already, which means those of you that are not paying attention should pay attention more. It might not cure everything, but it couldn't hurt, right? So I'll show you how to do this one, and I'll give you another one. Does anybody think they got it? All right, so if you weren't paying attention before, I would encourage you to pay attention now. Might not solve everything, but it can't hurt. All right, so what we're going to do is we're going to pull out that 3 first. When we do that, that becomes x squared, right? Because 3x squared. This is going to become 8 over 3x. And we don't bother with the 4, right? Notice that'll get us back to this. Everybody cool with that? We cool with that? All right, don't skip steps. We want to make this a perfect square so we can make it look like that, right? So right now we have a square and a rectangle, right? And we want to add on half that rectangle and square it because that's going to be the dimension of the square we have to add in, right? So we cut that guy in half. What's 8 over 3 divided by 2? Isn't it 8 over 3 divided by 2? Division happens on the bottom, right? So 8 over 6. And of course we square it, right? We cool with that? Now, when we do it to the other side, we didn't just add 8 over 6 squared. We added 8 over 6 squared times 3, right? Cool? And now it's balanced. This is a perfect square because that's why we did it. And that perfect square will be x plus 8 over 6 squared. Now, could you simplify as you go? Sure. Is everybody good with that? Let's simplify before we move things around. Are we good with that idea? Right? Cut it in half and square it. Add it to both sides. Make sure to factor in the 3. 8 thirds divided by 2 is 8 sixths. Does that make sense? Right? Division happens on the bottom. Right? Good question. And square it. So I'm going to simplify before I move stuff around. This right here is 4 thirds, right? Now, this right here is 8 divided by 6 squared. So we have 8 squared, which is 64, 3 squared, or 6 squared, which is 36. So it's 64 over 36 times 3. How do you want to solve that?
Bottom one first and then top.
3 divided by 36. What's 3 out of 36? 1 out of 12, right? So it's 64 out of 12. You dig? Right? That's 1/12. 1/12 times 64, 64 twelfths. Both those are divisible by what? 2,
4.
but also 4, right? 64 divided by 4. What's 64 divided by 8? 8. So 64 divided by 4 is 16. What's 12 divided by 4?
3.
16 thirds. And now we move it over. Got to get common denominators. How many thirds are in the number 4? 12, right? Because 12 over 3 is 4, right? So we've got 12 thirds minus 16 thirds. How much is that? 12 thirds minus 16 thirds. It's going to be negative. Negative 4 thirds. Again, why? Because there's 12 thirds and 4. Minus 16 thirds is negative 4 thirds. It's just a coincidence those numbers are the same, okay? Woo! Did it. We pulled out the 3, even if it's not nice. We cut it in half and squared it, both sides. Again, show the steps so you know you got to times it by 3. Okay? And balance it out. A lot of you guys are forgetting balance it. It's perfect square. What's the hard part of the math? Like the squaring and the multiplying? If you're stuck on that, that's okay. Raise your hand. I'll help you. I'll give you another one. Let's do 5. Plus, let's do 8 again. Go. Do it. Here's the problem. Yep. Notice it's a different problem. I'm showing you the same steps for the old one, though. Does that make sense? So you can see both. This is not the same as the last problem. Just to be clear, that's not the work. You feeling good? Try it. Need a pen? Need a pen?
How do you cut it in half?
Well, when we divide something by 2, remember multiplication happens on the bottom? So that 8, when we cut it in half, would be a 4, but remember we already had to divide it by 5. So it's 8/5 divided by 2, right? What's 8/5 divided by 2? 8/10. Yep. So Olivia?
And then don't forget to square it.
Right, we know we got to pull out the 5. You dig?
Wait, bro, I thought it was 10.
Hold on. So, right, we pull out the 5, right? Now, what we have to add on is this guy squared, right? And divided by 2. So we cut the rectangle in half. What we have here is 8/5 cut in half.
Trying to bully you.
Right? Now, in order to balance this out, I didn't just add this, I added this times 5, right? With me? What does it mean to square a number? So it's 8/10 times 8/10. That's what that is. This is also 64 over 100 times 5. So we have this. Multiplication, not a mixed number, okay? What's 5 divided by 100? Think of it as a fraction, 5 over 100. How do I reduce that? Well, 10 out of 100 would be 1 out of 10, right? So what's 5 divided by 100?
What's 5 times 5?
Right? Isn't that half, right?
I know, I'm tired.
20, right? 5 times 20 is 100.
I got it, but I don't know how to do the math.
So this becomes that. That's that.
I think I'm being
So just move it over by subtraction. This all becomes
divided by 2, 4, 10, 5, that's 4, 5,
All right, here we go. Yeah. Don't worry about this. It's a separate problem. Let me do this one. It's very similar. All right, here we go. Remember, there will still be no calculators on the quizzes. That's fine. All right, here we go. First thing, I pull out the 5. 8/5, right? We cool with that? I pulled out the 5, right? Now, to complete the square, I have to add something that wasn't there before. And it's going to be whatever this is, half and squared, right? So what I add on is this cut in half and squared. Right? Now when I do that, I didn't just add on 8 over 10 squared. I added on 8 over 10 squared times 5. Right? You see what I'm saying? 8 over 10 squared is 64 over 100, right? Times 5. It's okay as long as you see your mistake. Don't try to correct it. We're not turning it in. Make sure you see your mistake and know how to correct it. 5 out of 100 is 1 over 20. So that's this. So we did that to both sides. I can reduce that, obviously, but I won't. This will become this. All right, algebra, listen up. I need way more out of you guys. Quizzes this Friday. We are not slowing down. We've got a lot to get through for the rest of the year. You need to ask questions and try, and that's fine if we take up time doing that, but we waste way too much time in class. Turn around. Parker. That's what I'm talking about. Get out of here.
Parker, pay attention.
I was playing the magic square thing.
Aimed at you.
Write your name on it and stuff.
Do I still get self-development
Yes,
for
I
it?
will.
Can I like stay until like the bell rings and then make my way to Oakwood and Mr. Franks gets to
Top
and
thing.
that's it?
You can do whatever you want, but do I need to write you a pass or what?
No, I'm upset with him.
Okay, well, I can't guarantee it will be consequence-free, but you can obviously do whatever you want.
Probably been told.
You just want it in the mid.
Don't make bad decisions.
Mac, do you just want it in the mid?
Okay, so here's the deal.
Yes. No. Maybe so.
I'm going to sign for geometry, but right now you don't know your algebra, so we need to figure that out.
Do you just want it in the bin?
I'll take it. Bye.
There's probably a flaw in it because it was me and Troy.